All right, we'll look at a couple more problems from page 30. I put 306 here, but it's actually 303, isn't it? Page 303. All right. So page 303, number 46 and 48. So they have, like, the shapes are weird. So just use what you would think of normally from geometry. If I have two shapes that are sort of stuck together and I know how to do each shape separately, then I'll do each shape separately and add them together. So this one is going to be the integral from 0 to 1 of square root x dx, because this part is square root x, and then this part is x squared. So that's plus the integral from 1 to 2 of x squared dx. By the way, what do you think is happening at x equals 1 to this piecewise function? Do you think this function is continuous at x equals 1? Do you think it's differentiable at x equals 1? This function is continuous but not differentiable at x equals 1 because that's a cusp right there. The direction suddenly changes. All right, I won't go too much into that, it's just a little sideline. All right, so to do these, this one I could do straight away, but this one I want to change the exponent. So I'll just change that exponent, and just to be consistent, I'm not going to start doing this one. I'm just going to keep everything sort of in the same place, and then I can do my antiderivatives. We'll do the antiderivatives for all. Raise the power 1, we get x to the 3/2 power, 3/2 in the denominator from 0 to 1. This one's going to be x cubed over 3 from 1 to 2. Raise the exponent 1, divide by the new exponent. That's what it's all about here. All right, so this is going to be 2/3 times. So first I'm going to put in the 1, and I'm going to get 1 over 3/2, which is equal to 2/3. And then I'm going to put in the 0, and I'm going to get 0. So I don't have to write the -0, but I like to write it to remind myself as if I'm checking the work back, like, oh, did I really put in the 0? Yeah, I did. All right, because sometimes you put in 0, you're not going to get 0. All right, and then plus this one, we're going to have 8/3, our favorite number in the world for some reason, minus 1/3. All right, so this is going to give us 4/3 plus 7/3. That area is 11/3. See how quick we can do these things? All right, what about this one? Well, I want that blue area, right? So what I do is I do the integral, and then I just subtract out the rectangle. I need to know the area of that rectangle. It's not entirely trivial. Like, what is even the length of this rectangle? Well, it's 5 pi over 6 minus pi over 6. So the length is 4 pi over 6, which is also known as 3 pi over 2. What's the height of this rectangle, huh? What's the height? Well, since this function is sine and we're at pi over 6, the height of it is sine of pi over 6. So the height is sine of pi over 6, which everybody knows is 1/2. That's why I put it exactly in between the 1 and the 2. Pretty clever, huh? The 0 and the 1, I mean. All right, so that means that the area of the rectangle, I shouldn't have put equals here. These are really just side computations. All right, so the area of the rectangle is length times height. I mean, I guess usually the length and width are base and height, but whatevs. So this is 3 pi over 2 times 1/2, so it's 3 pi over 4 is what the area of that red rectangle is. Sorry, 3 pi over 4. Just calculating the area of that rectangle. Then I just go, the area of the blue part is equal to the integral from pi over 6 to 5 pi over 6 of sine of x dx minus that rectangle 3 pi over 4. Right, so I just subtract out the rectangle. Subtracting out the rectangle. All right, so now I have to do this integral though. So the antiderivative of sine is negative cosine. And we're going to go from pi over 6 to 5 pi over 6. And then I have minus 3 pi over 4. Now I plug in so I'm going to have negative cosine of 5 pi over 6. I could have factored the negative out. Maybe that would make it easier, I don't know. Minus negative cosine of pi over 6. But then I still have this minus 3 pi over 4 hanging out over here. And now I have to know what the cosine of 5 pi over 6 is. Cosine of 5 pi over 6 is negative square root 3 over 2. So this is going to be positive square root 3 over 2. And then I have minus negative, so that's going to be plus the cosine of pi over 6, which is square root 3 over 2, so the square root 3 over 2. But I still have my minus 3 pi over 4. So this equals square root 3 minus 3 pi over 4. That is what that area is. Hey, you know what's cool though? That means that the area, without subtracting out the rectangle, that area from pi over 6 to 5 pi over 6 of under the sine curve is square root of 3. See, these are the kind of things that I just find really intriguing. All right, so there you go. Your homework is page 303, number 27 to 47 odd. Have a ball.